Thanks, Jan. Welcome to this presentation. I will be speaking of obviously notebooks and geodata science because I'm a GIS engineer. So let me introduce myself to introduce the subject. I'm Nicolas Roelandt. I'm a GIS engineer at Gustave Eiffel University, and I work for researchers that have trouble to spatialize their data or that are not cartographers, so I make math for them or spatial analysis. And to do that, I use a lot of notebooks. Pretty much all of my work is in use notebooks. I'm also part of the notebook work group in France, where we investigate the notebook thing, the object, what it is, and what we can do with that, and what's the limitation of notebooks actually. And I'm in this group and also part of the OSGeo community. And previous edition and even in this edition, people use notebooks, but nobody speak about the notebooks, the actual thing. So I say I might jump in. That's my subject. So to define what is a notebook, I steal or quote Stephen Wolfram. So he said that the idea of a notebook is to have an interactive document that mixes code, result, graphics, text, and everything else. And I think the important things in that quote is that it's in an interactive document, so you can interact freely with it, and that mixes code and text. And then after that, you get result. It might be more text, it might be a graph, another output. And it's the core idea is from light-array programming. It's something that was thought by Donald Knuth, you might know him. But it tells us where you should be referred to instruct the computer what to do. We should tell other human beings, what we want the computer to do. It's not to say, do that to a computer, but, oh, I ask the computer to do that because I want that. And I get this result. So it's the core concept of literate programming. So you give instruction to the computer and you get information, you give information to the reader. It might be yourself or it might be another reader. So it's a notebook is a computational document that is interactive, that mixes code and text, and should be readable by a computer and a human. Yep. So let's get back quickly many years ago. In 1978, Donald Knuth created tech to create documents with a computer. Later on, LaTeX was created to make macros around text to make it easier, yeah, to use. In 1987, Donald Knuth created Web, that was a mix of LaTeX and Pascal, so you can have a computational document. And there was also the C Web with LaTeX and the C language. At the time, the first actual notebook was created in 1988, so it's pretty old actually, by Stephen Wolfram. It's called Mathematica, so obviously it was a notebook on math. With its own language, math language. In 1992, Knuth coined the literate programming thingy. In 1994, sorry, there is the creation of No Web, which shows not a fork, but another thing similar to Web, but not limited to Pascal. And also we have HTML output and plus LaTeX output. So it starts to have multiple languages and multiple outputs just from your document. A little bit closer to us. In 2001, there was the IPython interactive shell that was released. So you can write in your command line Python. Please get it. In 2002, there was Swift. It was something built from the no web idea, but where you can mix R and or S code and get HTML or LaTeX output. In 2005, SageMap, again, it quickly became a notebook on math. And in 2011, the IPython tool became a browser-based interactive notebook. It was the first one to do that, and they get some knowledge from SageMap. So the IPython community and the SageMap community were pretty close, and they benefit from each other. In 2012, there was the Knitnar engine, which from the R world improve what Swift did and take the whole computation of the document with LaTeX. So you press a button and it compiles the document to take into account cross-references and citations, and at the end you have your PDF or your HTML page. Swift didn't make that. You have to cross-compile things beforehand. So it's all-in engine. In 2014, there was the Markdown and Jupyter notebook released. I will speak more about that later, so I will get there. In 2015, for the people who like Java, there was actually a notebook written in Java, it's Apache Zeppelin. I never used it, so I won't make any comments on that. In 2018, there was the Observable notebook released, and in 2022 it will be Quarto. I will speak about only those 4 tools, sorry, because they are trending in data science. I won't speak about org mode, but because it will be hard to explain. I don't have a full session, I just have 20 minutes. So there is a lot more on notebooks, but those 4 are the thing I think trendier and funny to use for some of them. And I tested them for geospatial, so I can speak about that. So let's talk about Jupyter notebooks. So they are very popular and well known. Anybody has ever used Jupyter notebooks? Yeah? Yeah, pretty much everyone. So they are well known. At first it was only Python, R, and Julia, but they quickly add new kernels to connect to new other languages. So now you can connect to more than 100 languages and things. So you can do a lot of stuff in Jupyter notebooks. It's Markdown and code cells. Each cells are very distinct. And the file format is JSON. I think it's for me the big issue. There is a good integration with IDEs, especially in the Python world. So there is a very good integration with VS Code or PyCharm, because actually Jupyter notebooks are not really good IDEs. They are trying to help you write Python code, but they are not as good as VS Code or PyCharm might be. So what does it look like? So you have Markdown. Everybody's something like, you know already. So this is a notebook I stole from Grass, the Grass community, and you have cells. Markdown cells, and then you have code cells that you can run. You can run each cell individually by itself, or you can run the whole document if you want. So you can access Python and or other geospatial libraries. So the notebook itself doesn't provide any geospatial insight, you have to, it's provided by the language you use. So Glass community has created several notebooks in Jupyter, so you might want to have a look to it. But you need a server, a Jupyter server to run the notebook if you want to edit it. So you forget to use just Notepad++, it's or VS Code. You have to run the Jupyter. And Markdown, I think it's my personal opinion, Markdown editing in Jupyter Notebook is sometimes a little bit tedious. Let's speak about R Markdown. It's not a JSON file. It's from the beginning, it's a Markdown file with code cells in it. So you can edit it with any text editor you want. It might be VI or Emacs or whatever. Or even Notepad from Windows. It should be okay. It has great integration in IDEs, but especially in RStudio because it's the same company that builds R Markdown and RStudio, so they make sure everything works well. It's mostly used in the R world, but not only. And it's not limited to R. As you can see, there is more than 50 engines in Knackner that you can connect to other languages like C, Python, Fortran, for example, or SQL. So you are not limited to R. R Markdown is just a syntax, pretty much. So let's have a look, so we can compare a little bit with Jupyter Notebooks. So we have a YAML header, where you can provide metadata, and you have your code blocks that are fenced by free backtick. It starts with free backtick, and then you have free backtick. But everything is text. It's plain text. So you can write your Markdown code, your Markdown text in it, and include it. And when you render your document, you can have the whole document with outputs inside your document, but you can also run specific cells if you want, and you have also option to run cells above, cells below. The funny one. Observable, it's a JavaScript notebook, made for data visualization. It was created by the creator of D3GS, you might notice. The current Observable platform is closed, but the runtime is open source. And the libraries are also open source. So you can, actually, libraries are often also notebooks. So public notebooks are free to use and share. So you can load a notebook to access function from the notebook. So it's pretty fun to use. You can make easy integration to website. For example, you create a map with a notebook, put just the iframe in your website, and just a link to get back to the notebook so people can get access to how you created the map. Let's talk about the geospatial ecosystem. So it's quite young, maybe 1 or 2 years old for some libraries. You can make graph and maps with plot, but you also have access to Bertin.js to make thematic mapping. So it's created by a French cartographer, and it took several, it's an opinionated mapping tool dedicated to thematic mapping. You can also access to spatial operation with GeoToolbox. And you can do some projections. You can also access to other data format than JSON with GDAL, with a port of GDAL in WebAssembly. So in GeoToolbox, for example, you can do buffers, centroids, you can clip, you can compute bbox. It's not a full-featured JS like we are used to, but you have still some tools for basic operation. So this is actually not live, but I will show you the render code afterward. So in this block of code, for example, I get the world.json from, I think it's Natural Earth. I filter Africa. Actually, it's not my map, it's Nicolas Roelandt map. I just stole the code. We all do that, copy and paste. It's how we work, obviously. And then we draw a map. I won't run onto the parameters if you want to show more. If you want to see more, you can access to the notebook. It's on, and so actually, yeah, this is what the code rendered. So I can have that. I might have done the same for Python and R. Actually, when I was there yeah, that's code that have been rendered. I just put the line, the code line, and that has been rendered. Okay, so Bertin, it's working. The last tool is Quarto. It's pretty new, last year. It's a tool made for scientific and technical publication. It benefits from all the experience from R Markdown. Actually, I think it's better. The syntax is a little bit better for some things than plain R Markdown, the old R Markdown. And you can have various outputs like this presentation is Quarto document actually, but you can also have reports in Word or PDF, or you can also have website, wikis. It works with Pandocs, so you can access to all Pandocs outputs you can get. But it's limited to 4 languages, Python, R, Julia, and Observable geos. That's why I was able to create a map within this Quarto document. Because with Quarto, you actually have your Python and R and Julia installation, but Observable is shipped with Quarto. The runtime is shipped with Quarto. So let's talk about the limitation. So the cell execution is not linear, not necessarily linear. If you run the whole document, it will be linear, but if you run each cell and move, change things, and get back to another cell, at some point you might get lost of the current state of all variables because the variable state might be hidden. So the tip is to, from time to time, run the whole document to get a clean state of everything, and it will be okay. Notebook can be very messy. Actually, I have an intern that wrote 6,000 lines of code in R Markdown, and I open the document. I say, "Oh, I won't run it, never." And I tell him, "Okay, you have to split it in maybe 5 or 6 parts to make it run," because it was actually several analyses. So it's a source of bad habits, actually. And it doesn't care about software environments. You have to care about the software environment. The notebook won't do that for you. So if you are like me into reposable science, you have to take care of that yourself and think about it. It helps to understand what the people are doing and what they are wanting and how they process the data to get their results. But so it's good for reposability, but it's not perfect. You have to take care of software environment. So there is this presentation at JupyterCon by Joel Goss called "I Don't Like Notebooks." You should look at it. There is lots of meme and actual very good points on issues. It's more on Jupyter notebooks, so all those issues might be not present in other software. Let me conclude. Most training notebooks that I show you today can do geospatial stuff. Most are multi-languages, except Observable, which is only JavaScript. The capabilities are the same as the language you use. It's great to interact and play with, but there are some caveats. Like it can be a messy document. It doesn't encourage modularity. So you have to take that in account and maybe rework afterward. You are on draft mode, and then you export your function and create modules from it. And the reproducibility is quite good, but you have to take care of the software environment. If you have any questions, I think I'm on time. So we have time for. Thank you.